You know, for the camera, of course, yeah. I'm joining with my Weka personality. Can you use the microphone? I'm not bad, actually. A pretty handsome guy.
All right. Nobody's there, but we're starting soon.
Okay, hold on.
Test. Yeah, microphone's working.
Okay, then I'm getting out of this. I'm publicizing this link. Right click. Copy link location. There's this auth user equals 0 thing at the end of the link. I don't care. I paused it. What is that?
We can talk about, before we get into D stuff, did you have a look at the Apple MacBook announcement?
I haven't seen it.
No. I get the sense they finally, this is the year where the tide is shifting against them. Even though they have this great fortune of having Samsung's phones exploding, literally. That ought to be helping them a lot. It's helping them a little. But they did such a big design change with their laptops. And I just think they start to alienate people.
Oh, I was alienated by this ThinkPad, which I thought was I was getting the same cool design as the previous one.
Mm-hmm.
Keys moved around, keys disappeared, and the screen is this wide angle thing instead of, why do I need this one? So maybe Mac is...
Well, it's better for video, 16:9.
I know, but I thought ThinkPad is a business-oriented thing.
So you're an Emacs user, right?
Yes.
Do you need the escape key?
Oh, I heard about that. Somebody, VI has
VI
that.
needs it, right? But
Yeah.
Emacs doesn't need it?
Emacs uses the escape key,
So
but
you can remap everything.
Alt is, so if you do escape and then hit the key, it becomes meta, that key. Escape, release, hit, do something.
Okay.
But in Emacs, modern Emacs, you can use the Alt key to do the same. Like escape I is the same as Alt I. So, and nobody uses escape, as far as I know. Okay, I'm publicizing this link. Send. Public. We're public. Hi guys, anybody over there? Awesome. Yeah, so I heard they removed that key.
They added this OLED strip along the top where I guess you used to have these function keys,
Uh-huh.
which looks cool. I mean, it looks very cool. But
I'm looking for its pictures now.
I'm changing the design so dramatically. And then, Microsoft announced their big thing yesterday, which actually looks super slick.
Okay.
It's picture like a screen that's held on like a little pedestal that you can take off, hold it in your lap, or just lay it down on the desk and write on it with a pen. But it's really gone back to Apple's really cool iMac designs that they used to do.
Mm-hmm.
And
hello.
Oh, hi.
How are you doing?
That's great. Good to see you or hear you now.
Yeah, I got a better microphone.
Cool.
How are you doing?
good.
Just great. Only 2 of us so far.
Okay.
It's okay.
I've been looking forward to this. I've been watching Mir for the last month or 2. It's been making some good progress.
So yeah, so you've been playing with it then?
No, I haven't really used it yet. I haven't had an excuse to use it yet, really.
Okay.
I've been looking for one, but I haven't found one yet.
Cool.
Well, the thing that caught my attention was that if you can trust the numbers that were published,
Yeah.
the numbers are very good.
Yeah.
And for all of the interest in, big data and machine learning stuff, there's probably a market there.
Hey, Andrew.
How's it going?
Hello.
Great. Good to see you.
Yeah, I've been busy. I think I missed the last one.
We didn't connect last time. That was only John and myself, and we didn't have anything interesting anyway. Yeah.
Who's there now? Is John there now?
Not yet.
I guess he's coming.
Yeah, the traffic may be worse today because we had some drizzle. Nothing to write home about, but the roads are a little wet, and you never know what happens with that.
Yeah.
Traffic around Sunnyvale's gotten worse this last month.
Well, yeah, it's been steadily increasing. Without the rain, the traffic has been increasing.
Crazy.
Oh, Trotman, how have you been? How is school?
School's out for summer.
What? It's not summer there.
Sure it is.
Everything is upside down over there. It's not summer yet.
Well, I mean, it's the last exam that I'm involved with is tomorrow, and then it's the school or the university summer holidays.
Oh, okay, yeah, it's getting into summer. Sure. Great.
Yeah, so I have to mark exams, which always sucks because it reminds you how dumb half the students are. But then occasionally there's a script that shows how smart 1 or 2 of them are and that they should be there. And then it's summer, research time.
Do you get to do anything with D?
I haven't for a while. I've been encouraging people here to get involved with D and to have a look at D. I had a student that's taken a quick look at it, but the usual concerns people give are the concerns which we already know about, which are, for example, how much time should I invest in a programming language which may or may not become mainstream?
Yeah.
It's a reasonable question, right? It's to that point at which it's facing, the potential to break big time into the programming arena, and somebody has to take that leap, and somebody has to promote it. But the same thing would have been faced by Perl, the same thing would have been faced by Python and Dora and everything else. It's just that D's facing it now.
Are you aware of the new Romanian employees or graduate students that the foundation has?
No.
Yeah, now we're paying 4 students under 2 professors at the Polytechnica Bucharest, or Bucharest, and they're doing real work. Andre gave them some simple, trivial tasks, not trivial, but simple ones to get them know the code, the runtime, Phobos, whatever. And one of them is especially a great assembly level compiler type guy. So we'll be paying money, and I mean, both fortunately and unfortunately, I presume the money paid is little because student grade Romanian wages, and it seems great.
Oh, cool. What I've been working on recently has been SIM.
You're breaking up. Can you repeat, please?
So what I've been working on recently is SIMDC. You know, how much, I've got a horrible echo, but how much support is there for SIMD instructions directly from D?
I am not that familiar with that feature, but I know Manu has pushed for it for years, and people have made it better and better. Whatever they needed, they implemented it. I'm under the impression that it's good, but I don't know the details.
Right. Good. Yeah, I'll have to look into it. Yeah, but no, I mean, I wanted to get a lot more D done, but you know, during the teaching year, there's very little programming happens at all. I do have a project, which is going to sound like everybody's project, but I have some ideas on a source code editor that D would be perfect for, because it has a lot of support for many of the things which are a pain to deal with, like, you know, all the UTF-8 stuff. And I do intend to get back to something I noticed, I guess, a month or so ago, which is the Phobos support for UTF-8 and Unicode is several years old. I posted a message on the boards, and somebody basically said, you know, it's open source, do it yourself. But there are tools, no doubt, that there are tools to process the Unicode data files to be able to generate the source code. And it's a case of finding some time to sit down and do it. And I intend to do that.
Good to see you again. Yeah, you hosted
You're
one
Ali,
of
right?
yes, and
Yes.
you hosted one of our
I did
meetings
once, yes.
at Hacker Dojo. Yeah, Chris, right?
Yes.
So we have Chris here now.
Hi,
Hi, Chris.
Hello.
Is this your second time?
this is my second time.
Yeah. So what happened since then? Have you looked at D?
I haven't really looked at D, no.
Uh-huh.
I have this funny interest for D, which is not a genuine D interest, but I believe D could be interesting for my business, which is tamper-proofing, and whatever its infrastructure, it would be some of the biggest unknowns for me. So that's why I wanted to keep it in today.
Oh, great. If you have any specific questions, or if you hang out after the meetup, after Ilya's talk, we would
Sure.
love to answer any
Yes.
questions.
Is this a 3-person meetup or?
We usually have more, and we have 2 of our regulars online this time.
Yes.
And from now on, because they live elsewhere. Yeah.
One more maybe on the way, and then
Yeah.
the guy who's going to actually speak, he'll be joining.
Yes.
Somewhere from Russian time zones, I'm presuming. He'll join from his 4:30 a.m.
Yes. Oh, poor guy.
It's dedication.
Yeah, but he is an amazing contributor. He did Mir Glass, which beats any other competitor out there. He wrote this with D, and he's going to explain the runtime requirements that he had to put in.
Yes.
He changed the runtime, which is only in LDC right now, LLVM's compiler right now. Okay, I don't know much, but I'm waiting for him. And Benton, I forgot to ask you, how have you been?
Good. Things are going well out here. I'll probably be going either to LA or Orlando in 2 months. for my next work assignment. But I haven't heard which one yet.
What do you mean, long term or a few weeks?
6 months.
6 months. Oh, I see.
It's a rotational program. So I was in Sunnyvale for a year. I'm in Philly for 6 months, and I'll be
Okay.
yet again somewhere else for another 6.
I'm going to Tel Aviv. 5th of November, I'll be in Tel Aviv again for my second headquarters.
How are you liking working for Weka now?
Very much so. You know, I don't interact with them daily. Obviously.
All on the record, guys. It's just
Yeah,
we're broadcasting.
we're public. Yeah,
That's true.
very much so.
great. It's great.
And I can tell you from my so my experience with D has increased, obviously, because earlier you could say I was a hobby programmer, but what I see at Weka's code and what I contribute, it's really amazing. And I get more into D by working at Weka. It's very much fun. It's amazing. And I tell the next woman, a VP of marketing who sits next to me right now, and I constantly turn and say, D is great. Wow. When it works, of course, but there are times it doesn't. Hey, Shadek, good to see you.
Hi, just checking to see if it's working or not.
You connected. Awesome. Ilya is not here yet. How have you been?
Fine, how are you?
Yeah, great. Have you been using D lately?
Yeah, to some extent. I've been rewriting my PhD program in it because, like, the C++ version get unmanageable, and yeah.
So you're gonna get a D version that is unmanageable.
Actually, I learned quite a lot, and the focus has sort of shifted a little bit, so it's not unmanageable anytime soon, I hope.
Of course, cool.
Yeah.
Oh, the foundation is just talking with Sociomantic these days to finalize the dates of the next DConf.
Okay. So it's going to be in Berlin again?
Very likely. Because, I mean, it's because nobody proposed any other location, and it'll be again in Berlin, the conference, probably.
Okay. That sort of sounds good.
And yeah, probably the same venue too, because everybody seems to be happy with it. Works great.
Yeah, I mean, the location was quite nice.
Yeah, convenient.
What date are they thinking of? Is this May again?
Yes, it's not finalized. There are 3 candidates. One of them may be beginning of the week, if I'm not mistaken, like Monday, Tuesday, Wednesday, because of the availability. But we'll see. I don't want to say anything. Nothing is final yet. Same with June. Even a June date came up. But, I don't remember it much yet. We'll see. And let me repeat something which is already on the forums, which I've already said to Trotman, that now we have 4 actual employees for the foundation, graduate students from Bucharest Polytechnica University. They are actually working real stuff, and I interacted with one of them. They asked a question, and they are improving the Phobos, runtime, whatever. They are in the learning mode right now, but the foundation is paying them for their time, and they are working on real stuff.
Okay.
That's what I know. Andre is on a trip. That's why he will be offline for a few days. I mean, he will connect, of course, but he is not active at the moment. That's what I know. We have Chris here, who's attending for the 2nd time. We have Trudat here. He is the co-organizer and the main guy, actually, lately, most active guy of these meetups. What's the time now?
5 minutes. 7:22.
Okay.
We were just talking about the some non-D stuff related to the new MacBooks. You guys have any opinions?
Well, when
I
we
haven't
see
seen
them,
anything about it.
Does it run Linux quite good?
So what do the new ones do? What's special about them?
They
it doesn't
remove
have an escape key.
yes.
How can you use VI without an escape key?
Control left bracket.
Great.
Is that right?
Do they still have a caps lock key? Then you can just replace the caps lock key with the escape. I mean, VI and caps lock doesn't really work together for me as well.
Yeah.
So,
When
but
was
they're still Turing complete, right?
Without an escape key, probably not.
That's true.
They got rid of MagSafe, right?
I don't know.
I've never heard of that.
The power adapters that pop off magically when you pull on them.
Okay. So is this good or is this bad?
Oh, after we finally got used to it, and I think people like it enough to take it away is like arbitrary. It's like saying, you don't need popsicle sticks anymore for your popsicles. We have something new for to hold your popsicles. It doesn't make sense.
Yeah. So when Apple is going to reintroduce the keyboards to tablets in, let's say, 5 years, everybody's going to be happy. And it's going to be an innovation having keyboards again connected to screens.
Oh, poor Steve Jobs.
Yeah, but those devices will not be called laptops, and they will be called, whatever.
I thought the more interesting use is Microsoft's desktop. What are they? Surface something or other they're calling it.
Yeah.
Looks like a Mac, behaves like a Mac, got the same CPU as a Mac, but isn't a Mac.
Yeah.
If only they could complete the trifecta, which would be to allow it to have something like Boot Camp, but for Mac. So you could actually run Mac OS. And it could be done with Apple completely.
But how's the support for Linux on those devices? I mean, are there drivers for all the modules inside?
It's going to be a problem. I mean, I've never heard of anyone dual booting a Surface Pro or something like that. I imagine it's difficult, but inside of a VM should be fine. Looks like our star is here.
Hello.
Oh, hi, Ilya.
Hello.
Good to see you.
Good to see you too.
So,
Okay.
have you slept at all?
Yes, few hours.
Thank you very much for joining us at such a weird time.
Thank you for the invitation. One moment. I need to figure out how I can redirect the stream. I found this yesterday.
Oh, there's John.
So you can run Linux on this. You can run Ubuntu on the Surface Pro 3.
Oh, you can.
Yeah.
I'd be scared to try, but I imagine it's possible.
Well, you lose your Windows off of it, and so you need to be worried about whether or not you can ever get Windows back for it.
Yeah.
Yes, or if you use your warranty.
You're it.
I think I'd be worried to spend the $3,000 on the Microsoft Surface just to try it out.
Surface Pro 3 is £519 from Amazon.
Yeah, it's a great product. I love it.
Hey, John.
Hey, Andrew.
Did you get my email?
Oh, you did send me email. Yeah, I'm sorry. We've had initiative planning. I don't know if you ever went through that, but it kind of keeps you busy.
Yeah, no worries. We're in no rush.
Yeah, I'll send you a reply.
Great, we're in no rush.
Yeah. By the way, I heard you were sent a laptop. Is that right?
I'm trying to get into the country at the moment. That's correct. Customs grabbed it. Because it's worth more than $1,000, I have to have an import license. So I applied for an import license today.
Okay, well that's great. That's
It's coming.
I'm John, by the way.
Hi, John. I'm Chris.
Hi, Chris. Are you a deprogrammer?
No, I'm not a full programmer, but I kind of like it.
Okay.
Yeah, Chris attended once before, and he actually hosted our meetups before we came here at Hacker Dojo.
Oh,
He's a
okay.
Hacker Dojo member. Are you still a member?
I'm still a member, but it's lots of money, so I'm not sure how long I can
Yeah.
stay a member.
That was a surprising thing for me. It was so expensive. You know, I thought about becoming a member. A lot of money.
Yeah.
Is it still in Mountain View?
It moved, but given its location, I would say it's in Sunnyvale.
Oh, so it's not still not behind 101 and Ellis?
No, it moved to Thomas Road, which I think is not too far from here.
Southwest. Especially. No.
Yes, so,
Okay.
but it's
Okay.
I think it's Thomas Road in front of it,
Okay.
but that's close.
John uses D at eBay. And Andrew Trotman was his colleague. They used D at eBay. And they have some contributions to the open source. eBay open sourced some of the code that these two gentlemen wrote. Yeah. Robert left us. So Ilya is trying to get the streaming going, I think, or
Screen share.
his screen share. Yeah.
Yeah, the stuff that he's working on is really exciting.
Yeah, amazing stuff.
Yeah. Do you understand how he managed to say it's completely compatible with both C++ and D? I didn't quite understand that. It sounded like you could use it as a plugin library without really worrying about any of that stuff.
For Ilya's work?
Yeah.
What I noticed was it's a C library, or meaning a C API in front of it, I think. If that's the case, then it can plug into
So he put a C API around it.
That's what
Maybe.
I
I
assume.
don't think so. I think it's all externed to C.
External C.
Here to see.
Hello, everyone.
Well, he does.
Have you seen my screen?
Yes.
Screen? Yeah. So dash quality is good.
Very good.
It looks good for us, but I'm gonna mute ourselves because we continue jumping. Or can we pick which screen to view? Yeah, like this maybe? Okay, we're good.
Okay.
We can still mute for accidental fart noises.
Yeah, I've turned my video off for bandwidth preservation. I'll turn my sound off too, my microphone off too.
Okay. Hello, everyone again. My name is Ilya. I am a IT consultant and statistician. Currently, I'm located in Russia. I will speak today about generic layer programming and the things that we should do to make it good for business. I'm very excited to have a talk with Silicon Valley. I have an internship approximately 8 months ago in Silicon Valley. It was amazing. So let's start. So the first thing in language, it's runtime and standard library. It's like phase for the language, and it determines where the language can be used because it has constraints for engineers, and any runtime is like a set of constraints and set of opportunities for engineer. So we need to understand where the current runtime is good, and the answers almost everywhere is no. It's not good in many fields, but like you can write very cool, fast, small text processing coroutines. So like few words about each field. Like PC console video games, the main problem is garbage collection, and some video games doesn't require very small delays. But for example, very popular games like Counter-Strike, Dota, like they need no delays or very small delays. So garbage collection can be used here. About async input-output and WebD. So WebD is faster than Node.js, but it is slower than many other C libraries for async input-output. And the problem is that the main problem is that we cannot write a good and fast async input-output with current runtime. So we have our constraints such as mutex suites and fibers, already existing fibers, and they are object-oriented. So our library will be object-oriented too. And for example, if you look into WebD internals, you will find that it's for each connection, for each data frame, it allocates it makes a lot of allocations, and it duplicates data between buffers. And the WebD API doesn't allow to write a faster zero copy, like for example, zero copy proxy for HTTP or HTTP2. So it's a very big problem because like an object-oriented architecture is like it is not obviously that it is not good for you. Okay, like you begin to work with it, and after a while you understand that it's not good for you. Like because a lot of different components are interacting each other, not explicitly, but implicitly, and this is a big problem for production. Then scientific software. With scientific software, we have the following problem. We are not high level enough to be used like scripting language. Maybe some libraries, and for example, Phobos can provide such functionality. But the deep programming language is too complex for data engineers, for scientific folk, and most of them will be happy more with Python, Julia, and like other languages like and systems like MATLAB. In the same time, science needs a very good language to write low level and very fast code. And this code should be C compatible, so it shouldn't have its own runtime. It shouldn't have like additional features, and it shouldn't have problems with portability and problems with version maintaining of very huge like libraries such as runtime. So scientific software, like, it should be either high level scripting language, or it should be low level like C. And sometimes some scientific software works with C++, but it's more like an exception than a rule. Embedded systems. Most of embedded systems do not need runtime, or has its like its own small runtime.
You can join in.
And like they have additional constraints like small memory amount, or for example, and of course we have problems with portability. Because almost many of them provide like a small subset of libc library, or just only or just full libc library, but nothing else. So we need to spend the time to port LDC compiler, and most of the time we will spend is to port D runtime, not like LLVM and LDC itself, but D runtime. High-level applications. So the same reasons D runtime cannot be used to write a very fast high-level applications. So the reason is the same, that we have an object-oriented runtime. Low-level programming, yes, the same. We just need a libc, and okay, and with small routines like. For text processing, for like daily programming, we are okay with current suites and matrices. So I have already said about garbage collection, and a lot of post was about garbage collection, and this is why is a reason why D is not popular today. I think it's because we have a garbage collection, and we have a high-level object-oriented library. Do runtime library. Do you hear me? Oh, please ping me that
Yes.
you hear me. Oh, okay.
Yes, we do. We're on mute, but we're listening to you very
Okay.
very well. Do you want
Okay.
to ask your?
Okay. Thank you.
Hold on.
Yeah, sure, maybe. Hi, Ilya. This is John Degenhardt from eBay.
Hello.
So I'd actually, in some ways, it's perhaps a minor point, but I'd like to maybe challenge some of your assumptions on the scientific programming aspect, especially the notion that that D is too complex a language. So I work with a lot of data scientists, and these data scientists are using Scala, and Scala is actually, in my opinion, a much more complicated programming language than D is, and so. And to a certain extent, actually, I think D could actually have a real future in a lot of the plugin places. And I was actually thinking you might be talking about it a little bit today, in the sense that if you look at what happens in, say, R, or like a lot of the Python libraries, when people need it to be fast, they go and write C code. And I actually think it would be fantastic if we had, if there were some packages that people could write in D instead, because I think people who are coming from a scientific programming or a data mining, environment would, I think they'd actually have a much better time programming in D than they would in C++. Anyway, that just a thought on that from my end. I don't want to hang up the meeting on that.
Big data.
Have you seen big data libraries?
No, I have not actually.
It is a Scala library for machine learning. It uses CPU and GPU, and it has a lot of models, including they say that it's very fast. Probably it is. Of course, it uses like different C, C++ backends, like optimized BLAST library and GPU libraries. But the problem with this library, like the Scala has the same problem for scientific programming like D. It's too high level, like it has a very big amount of features, like language, allows to write a very different code, and allows to use a very, very not obvious and not simple concepts. And it is, furthermore, it is object-oriented. So Scala has both functional and object-oriented style, and it's very, very dangerous to use an object-oriented style in scientific programming. For example, bitmatch uses this object-oriented approach to define a solid interface for different machine learning models. And this causes problems because some models works good with determined set range of initial parameters, and when the root class has already defined these parameters, but its values is outside of allowed range, we can have real problems. And the problem is that in 99% of cases, machine learning engineers don't study well like each model they use in production. So maybe they are good specialists in one field, but they haven't read a tons of articles in other fields. And when they start this model with not good parameters, this model works, but the problem is that it works, but it works incorrectly, and we cannot understand that it works incorrectly because we have like output that seems like it works, but it is not good enough. In the same time, in reality, it is good. But we need to go into internals, we need to understand all object-oriented hierarchy and find where we have problems with like tuning parameters. So having a plain, simple API is very important for science. And this is the reason why science has a lot of C libraries, not only because performance, but because simplicity of API, portability, like it's simple to understand and simple to use, and it's simple to integrate in production. So it's very convenient to use high-level languages, very high-level languages, like D and Scala when you build your own library, and you build a stuff for you. But it is a very big problem to share the stuff with another engineers. Because they don't know all internals, and it's a big problem to port this data, to port this software into their production and completely understand all features and all important API moments. So I will continue. Sorry for off topic. I will continue with D. So the D is too high level for D runtime is too high level for D. So we're trying to be something like Rust trying to be, or Go trying to be. Yes, we are much older than Go and Rust, but they have opportunities in these fields, because they have commercial support and they have a specialization. Like Rust is something to write safe desktop applications, mobile applications with good performance. It's not a language like they're not really system programming languages. For example, Rust programming languages used all the existing C libraries in its runtime. On the other hand, Go doesn't use, if I'm not wrong, C libraries, but it has a lot of assembler code. And if you need to port Go to another architecture, you need to write tons of assembler code because they don't want to use C, but they need to write. So they need to write in assembler, and it's very, very strange because they can. So they prefer to write assembler blocks instead of small C blocks, or like with small line assembler parts. And this is not portable. Like in LLVM, almost always you can write something. LLVM plus D, you can write a very portable code with like glass. For example, glass. It has a lot of operations with vectors, but all of them are portable. So it doesn't care like architecture-specific any architecture-specific features for vectors. So it will be, so if we have imported LDC and we port like CPU identification for CPU cache sizes, we can use glass everywhere. So let's start with this slide. The first is monolithic architecture. What's the problem with monolithic architecture? That, for example, in real world, when you work with system programming, you write, for example, very big project, for example, distributed database, or you write some stuff for embedded system, or you write a video game, like any from this. You need to be sure that if something goes wrong with the runtime, because it's very, very big, you can tune something and fix something and or replace something, and this will work. And in the same time, you just you don't want to have problems like forking DMD, then waiting while like or forking DMD fork like LDC, and be happy with its like integration. So when you fix something in the runtime, you need to be sure that other features work correctly, and so you need to understand them. So for engineers, like work with the runtime works on the runtime, so they should invest a lot of their time to improve the runtime for their projects. And many projects can be done without it, but the possibility to spend a lot of time, to spend a lot of money to tune and fix the runtime for production is a big problem. So, and when product managers see that we have such problem, he has such problem, he will probably decide to move to another language with already tested runtime, or with without runtime like C, or with minimal runtime like Rust, for example, which is based on already well-tested C libraries. So what I want to see is a runtime where with clear dependency graph, where each component is clear how to depend from another components, and where we can upgrade a version of these components and do not upgrade version for another components. So the API for this runtime, internal API, should be clear, it should be defined, it should be like a black box. And we should split our runtime into a few parts, like STDC, some generic routines which can be used to build precompile it all ready-to-use models, some small ready-to-use models, and these internal things should be clear, they should be separable, and they should be partially upgradable. So we need to more control about our D-runtime infrastructure in large-scale projects. And this it's very important to be deterministic, to be simple, to be obvious for commercial projects. The second is many language features implicitly depend on D-runtime, and when a new engineer looks to the language and he tries to understand if he can use a D-runtime, a D without D-runtime. What subset of language can be used without D-runtime? And this is not defined too. He needs to search forums, and there's no clear answers. So, a D language and D-runtime are not separable. The concept was to have one D-runtime and different standard library implementations, but reality is that we can have one single standard library, generic standard library, and we should have multiple building blocks to build your own D-runtime. Of course, some simple D-runtime for daily use, like current D-runtime, is okay too. The third issue is model initialization and model constructions. This is a very big problem because when you, for example, would like to replace a C library, it has all the existing API, and this API doesn't assume any. So you cannot just write the same API, because you need to initialize D-runtime, a lot of your models. You need to initialize garbage collection, and you need to link all this crazy stuff to your project too. So this is just a very strong API constraints for D to become a part of all of the existing big C infrastructure. And this feature doesn't allow us to move forward and to replace C, because if we cannot evolve from C to D in our production, in our libraries, we will not use D anyway, and we cannot just create a new world with only D and without C. So we need to have an ability to evaluate without huge problems and huge efforts.
Ilya?
Yes?
The runtime and module initialization functions, are they well known to the C world? Because I know you can call some functions to initialize the D runtime. Is that true?
Yes. But for example, let's take basic linear algebra routines. If you want to, you have different BLAS libraries to call such library, like you write code for such library, then the caller library don't know about D-runtime. It don't know that this component should be initiated.
Mm-hmm.
It is like API constraint, it's API problem. So you need to tune not only you need to tune also the high-level project. For example, you need to tune Julia. You can just open BLAS with runtime-based BLAS implementation just by linking another library. It is not possible. You need to initialize, you need to fix Julia to initialize the D-runtime.
Okay.
This is yes, for Julia it's not a big problem, but if you have a big infrastructure, this may cause problems because it's like domino. It's like one problem makes another problems, and like a lot of dependencies between components in C world make it very, very crazy. So it's like a red flag for like runtime utilization is a red flag for low-level scientific software. The next step, the next is a problem is very, very big, that our runtime is object-oriented. We have our exceptions, suites, mutexes, are objects, and model construction, runtime model information, runtime type information is object-oriented. It's object prediction too. Why it is not good? So the first one is that all these features are placed in garbage, are placed in a heap for garbage collection. And the second is performance. The third, that if we combine generics and object-oriented concepts, we have a lot of template bloat, and we have a not obvious architecture. You don't need a generic language, don't need an object-oriented concept. It may have it, but it doesn't require it. And so this is like something, the concept that was obvious like a few years ago when D started and D2 was started, but this concept was because I think that because Andre and Walter wants to be high level, very high level language with very simple API. But today is more constrained to build high performance software. It constraints like crazy because about this problem, because we have object-oriented features in the low level part of the language, in low level part of our D runtime. The problem with it, and this makes all other libraries which are based on this runtime and heavily use this runtime and object-oriented libraries. So we cannot write something like something like generic VibeD, because this generic VibeD will be used and will be based on already existing object-oriented infrastructure. I have saw some libraries for messaging, for RPC messaging, which combines object-oriented and generic styles, and it's not very, very good. The library itself looks pretty cool, but it's from a Japan engineer, but it is not something that can be used like, so we have different engineers, and we need this library to be understandable by other people. So if we have a production, we may choose a worse language with worse features, but it should be reliable, it should be simple. It is very, very important. We need to make, when we build software, we need to make it obvious for other people, for other engineers. And we can, and this is like object-oriented library based on object-oriented runtime wouldn't be simple and wouldn't be like obvious. You cannot just split this library into components. the integration between these components will be very, very high. We need to reduce integration between components, make it independent as much as possible, and reduce any and reduce any additional computations, like for example, like classes has. For example, we have problems with inlining when we use classes. There's a lot of when we use classes for buffers, for example, we makes a dozen of virtual calls just to get a piece of data. For example, WebD has a problem. It reads an input, standard input for application by one character. So it reads 1 byte, and then it switch event loop. So it's 1 byte, and then iterates all event loop, all green threads in application. So standard input in WebD is the slowest standard input in the world. And like this is very simple feature, but it doesn't work. And I have reviewed its internals, and it looks like it cannot be solved without API changes, at least very, very big and rework of internal API infrastructure. So it's very, very simple, but it can be solved like doing few hours. You need to spend much more time to do it. So low-level features shouldn't be object-oriented. In better world, we shouldn't use object-oriented concepts in D, except cases where we have where we provide an object-oriented interface for our clients. So, for example, if we distribute all the precompiled libraries, D libraries, which has an object-oriented interface. So, like this is good for old school like distribution model for software, but it is very rarely used today. So let's to see few examples about current problems with D runtime. In the left, you can see a very, very small function which compares two static arrays with a length of 3. It is a real-world example from cpuid identification, because like this 3 ints represent CPU family name like Intel or AMD. It says encoded strings in A and encoded strings in B. And you expect that A equals B. And this will work. But even if you turn on all compiler optimization flags, you wouldn't have good optimization here, and you won't, and your code will require D runtime. So it calls it gets runtime information about this type, and it passes to a runtime function at ec2. So probably it's like equals 2 arguments, and we cannot eliminate this problem. So we need to rewrite the left code. So we can just use like compiler flags to eliminate it. In addition, we have runtime model info compiled with our object file. So we don't need this information, and this is not a part of like a better C concept. The last one problem can be solved with LDC using LDC no model info pragma. LDC has also no type info, pragma 2. So LDC no model for removes like model information. The same problem. So to solve it, we just need to write or compile time for which or runtime for which loop for all elements, and it's like a small template which is used heavily in gslice and mir. To port it into your code, you need to write like static assert that I is less or equal g. So then we have unrolled loop here, and like the problem is solved, but we need to know all these cases where like obvious runtime count doesn't work, and these cases always about like arrays, assets, unit test assets, and and of course we cannot use function closures like delegates for functions.
Ilya,
Yes.
sorry to interrupt. And first, hi to David Nodlinger. He's an expert, and he contributed all these features, I'm pretty sure.
Could you repeat, please?
Sorry?
Could you repeat, please, the question?
Oh, yeah, no, I haven't asked the question. I said hi to David Nodlinger first.
Oh, okay. Hello, David.
He's an LDC expert, and he contributed much of these.
By the way, LDC team very good in terms of compiler support. They implemented a lot of features for mir. Without these features, mir will be impossible. They describe it, partially they describe it in Johan and Jelen blog. I will show you the links. These links. The last one is about some of these features. LDC has another features like very good inlining assembler. For example, I will show you this in cpuid. We have one moment. It is. We have cpuid function which should call a single instruction, and when we use standard assembler, we push a lot of registers to our stack, and then we read these registers back. So this function, this simple instruction, is like a function. So we cannot just inline this function because, or even if we inline this function, we will have a lot of additional instructions because DMD don't know which registers will be broken by this function, by this assembly block. It's a GDC and LDC. This code is for GDC, and this code is for LDC. And we can just call a compiler, an LDC compiler, which registers will be broken, and so the internal compiler logic will be able to efficiently inline this instruction into your code, and this is very, very cool. So, and also mir is based on assumption that some loops can be efficiently optimized with LDC. We haven't like a very big kernels like other libraries. For example, I'll show you. Like this is Blast kernel, and this is like all kernel, single kernel for all types, for both real and complex numbers, and it generates in very efficient code, which equals like to Open Blast assembler blocks. We use LLVM prefetch instructions in the loop. We use unaligned features, and we use vector permutations from LLVM to mix a real and imaginary parts. One reason why mir is more simple than other libraries that vector permutation for real and imaginary parts for complex numbers are done during copy stage instead of computational stage. So Open Blast, for example, do it during computational stage, which makes impossible to write portable kernels because compiler is not able to correctly optimize this logic in runtime loop. So, and this logic should be different for different architectures. For copy stage is not so important, and if we have some performance issues in copy stage, these issues won't affect the code. Like it's like small topic. Sorry about it.
But I still have a question.
Yeah.
So you've shown us, before the pragma LDC no module info, this one. So couldn't the compiler optimize this call, the type info call?
No, the compiler cannot optimize this.
But at least can it do some favor to basic types like static arrays?
What do you mean?
Like it sees it, there's a static array and type info for it is hard-coded somewhere. Instead of calling that function, can't it inline that somehow?
No.
Like cheating, basically, for basic types.
Maybe this can be done, but this wouldn't be like a good performance, because instead of comparing few values, like in this example, you will call you will inline a big function, which will compare for few. First, it will compare the pointers to the data. Iterations over the loop. Maybe I know that recently C compiler is able to inline non-generic functions from Phobos into code when when optimizer flags is on. So probably we can do this with runtime. But the problem is that it is not like obvious. So we haven't like pragma inline 2 or pragma inline false for this case. And it is best solution to always inline this function.
Okay.
Because we can compare like big arrays, and we need to have different logic for big static arrays and like small static arrays.
Okay, convinced.
So, okay. The next example is like model information. The previous was about type information. This one is about model information. Some language features, there's not a lot of such features, but they are. Like final switch requires model info because when we have a switch loop and we have a default statement, so we have an assert, like virtual assert if no flags is okay. And if we add a release to the compiler options, this part will be eliminated. So it can be solved just by adding a release, or we can just open an issue for DMD and runtime to replace D-switch error to change its API. So we don't actually need model information here. We just need a file name and a line number, like for assert errors. But this information should be known to write a Battersea library. Like it's like small information. The second example is about asserts, how we can override assert function. So we just add LDC no model info, and all functions here are nothrow, no GC, extend C, and they're not online. Extend C just to have simple names in assembly code. So we override the assert. It should be extend C. We use print, and one hack here is that we can just use file.ptr. So yes, file is a D-string, but in reality it is a terminated C-string. So it's okay to use printf here. Then we call just lib abort function. On the right side, we have two examples how this program can be compiled. The first one is a compilation with LDMD2. We have a default lib flag alias it to nothing. What this means that we don't link a standard library, because standard library already has the assert, and it looks like this the assert in the runtime hasn't like something like weak attribute to be replaceable. For example, it is replaceable with DMD, but not replaceable with LDC. I'm not a specialist in these terms of in static libraries, but like default lib nothing solves this problem. This is output, so we have a line number and file name, and we have an error that our program was aborted by abort. And of course the int main here is extend C2, because we cannot use a dmain function like with strings, because it requires garbage collection and it is defined in so this main is C main, it is not D main, but it works. Like if you define main like extend C, it will work, which is very cool. The second alternative is to compile it into object file with LDC and link it into just a program with GCC or Clang or Slang or another C compiler, and run it, and we have the same output, which is awesome, because just now we compiled a D program into object file and link it without any runtime, without any additional like compiler flags, linking flags with C compiler. So yes.
I have another kind of unrelated question. You said if you make main extern C,
yeah.
How about the arguments? Does it get the C arguments, or is it still a string?
It gets C arguments. It gets C arguments.
Interesting.
So it's just a normal C main with C arguments without D strings.
Wow, cool magic. Thanks.
So, so the next slide is about core exception. It has extern C extern C part, which contains the following declarations with its bodies, and all these bodies requires garbage collection and standard exceptions. So it's like why we need the main question why we need a garbage collection if we want to terminate our program right now. So, but we use it because all our runtime currently is object-oriented and GC-oriented. The bold text is for features for functions that require model information. But in reality, we don't use this. Use it only for D-switch. Probably sometimes it uses it with model information, but I haven't found a code example where first three model for prototypes occurred. So in common case, we just kill the second two for the assert, and as you can see, we have a special routines for unit test asserts. This means that standard assert and asserts in unit test is different asserts. Furthermore, I'm not sure if standard asserts. We need some clarification about unit test asserts. Does common asserts replace it with unit test asserts in non-unit test blocks is an open question. So we need these things to be defined in some internal documentation. It's it requires to just test it and to read a lot of internal code to understand some stuff. But the good point is that if we declare the assert and you'll be able to use asserts in our programs. And the not good news is that we don't need to define the unit test asserts because we can't use unit test without the runtime. So our unit tests without the runtime is just text blocks. They do nothing. They cannot be run it without the runtime because unit tests are run by the runtime. And we cannot just write a better C library for unit test right now because unit test requires more information about unit test are stored in model info. If I'm not wrong, I may be wrong, but probably it's stored in model information. Okay, let's move forward. As on the right, you can see the scheme of our runtime. So currently, today, all our applications are based on the runtime, and and of course our Phobos is based on the runtime. Some Phobos models can be used without the runtimes, probably many of them. But first, it is not obvious which models can be used with the runtime or which cannot be. In addition, Some functions depend on its compile time arguments, maybe nothrow, notgc, or maybe may throw and may cause a garbage collection. If you have a pure notgc nothrow generic code, you can easily use this code in C library, in better C mode, like in your D C library. But it's not obvious, and Phobos has not all unit test coverage for cases like purity, safety, nothrow, and notgc. So only part of the unit tests are marked, and we may have problems with backward compatibility, and we may have problems with different compiler versions because some parts of the runtime are nothrow notgc in one place and some doesn't in another compiler. It's a very rare case for the runtime, but they may happen, and it's like a risk for production. So the Phobos should be split into parts which are requires garbage collection, and the parts where we have guarantee that we don't have exceptions, we don't have garbage collection, and we can use like a generic code that can be just place it in our object files.
Ilya?
Yes.
Are we thinking about a new attribute like at the runtime, and then we compile? I don't need the runtime, and the compiler checks it. Is it possible?
Yeah, I think this is possible. Yeah, it's like a good. It looks like a good idea. We can propose this feature and to our team, our compiler teams.
Thanks.
So currently we can use. Currently, in most of cases, I just review the Phobos code to use this in my project, Better C projects. But the best way of using the current Phobos in Better C mode is compile time function evaluation. So we can use garbage collection, exceptions, whatever, in compile time. And it doesn't affect the Better C concept in any way. And this is awesome because we have a very cool and well-known for us library which can be executed in compile time. And the cpuid is a good example of this library. And why the Phobos, like small routines, should be packet, should be like standard library, but not due on time. So the Phobos and due on time should be changed. This picture. So we should have small generic Phobos which are packed with the and we should be able, and we should have building blocks due on time blocks which are packed with the too, but they can be replaceable and overridable by user infrastructure. Because we haven't problems with generic code because we can just don't use it, and we may assume that other dependencies which uses code will be crashed if we replace this code in another our components, because this code is pure, nothrow, and no generic, and no GC. So first I will show you an example, a code example. Like just any field. So this is difference between mir cpuid and core cpuid, that mir cpuid uses declarative style programming. This part, or this represents basic lib-adin information for Intel and AMD CPUs. this part of code, like for documentation generator, it doesn't use it by compiler. So this is like a real implementation. So we use std bitmanip bitfields. It's just a text mixing of methods which use flags like 1 bit in 32-bit integer. It supports also another all integer sizes, and we can override the type. We can set amount of used bits, and this is awesome because it significantly simplifies the implementation. So instead of looking into the std cpuid is writing like this way. Let's write a model. So model or like bad example, like array x. What we need to array x like we call a cpuid instruction. Then we define like a bit for array x. Then we like create explicit bit mask operation, and if we need to add a new instruction, we need to repeat the steps. In this standard library code, compile time standard library code, we can use a declarative approach, and we can just take a spec from Intel and from AMD and just write these lines, just copy paste this line from spec, from specification. And this is like, you probably, if you do so, you will have problems with bugs. If you have it, it won't be like copy paste like small bugs, but the opportunity to create a bug is much lower than in Core cpuid. Core cpuid also has bugs with CPU cache sizes. So its approach, first, its approach is not obvious. Like it's split cache size into cores count. Then few cache levels are splitted implicitly in the implementation. They divided by 2 because there is assumption that half of this cache is instruction cache and half of this cache is data cache, but the reality is different. The reality is that we have data caches, we have instruction caches, and we have unified caches. And for example, for server ARM CPUs, we also may have a different number of cores per unified cache. So we can have multiple unified caches, and each of these cache may have different numbers of cores. For example, one very big level 3 cache, and which works with 6 cores, and 2 small caches with sorry, my cat, and 2 small caches with 3 cores each. So like small topic. Then we move to our presentation. Beta C. So why not beta C and why beta C, not a beta C++ or not a beta system Java? Like currently D looks like something mixture of C++ and Java, and we have the same problems like in Java. We have the same problems like people have in C++. It's dependencies, object-oriented problems, portability problems. But C++ and Java has a big commercial support. And this is like chicken egg problem. because sorry, one moment. I have very crazy kitten. She plays with my pencils. Okay. Let's move forward.
We're still with you if you're curious. We're listening.
Thank you. Okay. Just my cat plays with pencils. Okay. So why we should go to the low-level direction, and does it is it low level so dangerous, like so not convenient? I think it is not convenient. It's pretty cool, and we can write with current very powerful D generics. We may have a very powerful abstractions for code, like cpuid example or mir glass, and in this field, we all the about ChickenNet problem. In Java and C++ has commercial support, and their libraries, their runtimes are like well tested. So if we and we cannot have a well tested portable runtime which is available on different architectures on different operation system without commercial support. The reason is very simple, because it requires to maintain a C++ runtime or to maintain a C++ template library and maintain Java library. This requires big efforts because these runtimes are really big, and D runtimes is big too. It's bigger than Rust runtime. Probably it's bigger than Go runtime. So currently, I think that we should go forward with only C runtime, and this is a good direction. The following list is about just list existing multi-language runtimes. Why multi-language? Why just we need a runtime that can be used for like multiple languages? First, what is runtime? Runtime, like it's precompiled code or system-dependent code, which allows a language to be used on defined set of operating systems architectures. And the D as programming language should be callable from other languages. So the Go concept is a language to write in applications, to write like server-side routines. The Rust language to write safe applications. But what's the purpose of D? The D is not concurrent in terms of safety. It is not concurrent in terms of simplicity. It wouldn't be never popular like simple like high-level system language, because it's complex and it requires like it requires like a system programming background to use this language. It doesn't. It may evolve to some like to some libraries which will be popular, but like language itself, it it cannot be popular like C, for example, or like Java, for example, because it's too complex. So we cannot compete concurrent with Rust and Go in terms of simplicity. When you see a Go code, it's like it's huge. In most of cases, it's much larger than D code for the same task. Go hasn't a lot of algorithm in its library. So when you read Go code, it's like a huge piece of code, huge piece of sources. But the good point about it is that it is obvious. So we can just read like oh, C program is the same. You just read a lot of code, but it's simple. It hasn't dependencies. You don't need to open don't need to open a lot of runtime code. You don't need to open Phobos code like you need to do in D to understand what happens, to understand the logic, and to understand if this is efficient or not efficient. So you just use Go and Rust like scripted languages. All these runtimes listed here, they either supported by companies which created these runtimes for their own commercial purposes, or this is a C library, or specific additions to C library like POSIX or Darwin Operation System has. So this is a reason, for example, why almost all code was which is portable, good, and low level was written in C. D hasn't concurrence among languages for high level, low level programming, high performance, low level programming. And this is our opportunity. This is a field where D can be really good, and this is a field where if we will work and we decide to move forward, we will have a very good chance to evaluate our production, evaluate existing libraries, evaluate existing not like subset of infrastructure, but all infrastructure during years, one part by one, from C to D. It is not a goal to evaluate existing libraries from C to D, but the goal is to have ability to write an application components in D which are compatible with all the existing C infrastructure, and this ability allows a D code to replace all the existing C sources. There are a lot of things where D generics are very good for low-level programming and for high-performance programming. For example, let's see the cpuid is one example when we generate using compile-time function evaluation, we generate a very cool API. Doing and we spent a very small time to do it, and it works like a C library, so we don't need to link the runtime here. The second example is static for each loop. It's here. So how it works. Another chain is like a chain of 6, 4, 2, 2, 1. So the 6 is like main kernel, main piece, and we have like a matrix, and we split matrix by rows, and to perform like good register blocking with kernel, we split by 6 rows. So we are able to store information from 6 rows in the matrix. And we iterate, so this is a compile time loop, and which contains internal runtime loop for 6, and it contains only ifs for 4, 2, and 1, because and y is compile time value, so this expression always evaluate to false for 4, 2, and 1. It's like, I'll just remove this so it will be more obvious. So we have an array like of numbers, which each number represents like an information, doesn't matter, it may be rows, it may be matrices, and we split this by 6, and we computes a data for 6 rows at once, for 6 values at once. And to write this in C, we need either to use a very crazy, it's very crazy macros as loops, which looks very, very weird, or we just use manual C code. And this code, like manual unrolling loops, which is not very, very good, because an F chain is can be just a compile time value, and it can depend on configuration. So you have a configuration which has a definition of register blocking, like 6 value, and this list of allowed vectors types. This is just, for example, for all BLAS is available for all level 3 BLAS for AVX and AVX2 double precision real numbers. So this is all you need to do it for AVX. The same for ARM, so it's very, very portable. In the same time, for example, OpenBLAS has tons of assembler code, and Eigen uses for different compiler backends, for different architecture sets. It generates like small microkernels, like the previous function, like this function, or like this function. Like this function, it's so Eigen generates this, like for this function, it has different backends for different types, for different architectures. But instead of this, we have just a configuration. So, and we have compile time code, which use static for each. This is static for each, and this is runtime for each. So, and this is like a very powerful concept to write a portable generic code, which are very close to metal. So, and a very good point about this approach, that engineer doesn't need to spend a lot of time for low-level tuning, and the abstraction of is more high level, but it is low level in the same time in terms of performance, in terms of possible abilities to optimize your code. This means that engineer has more time to think about concepts which can be hidden and may not be obvious that they can be implemented in common case. Like I will show you this concept. For example, it's like a lazy copying. So in common Glass implementations and the reference literature first performs a blocking and then it performs a computation. So copying is split from computation part. In Glass, because we have a very level concept and we use generic code, so we can experiment with different approaches, which requires a very big efforts in C and in C++ too, to understand what concept will be better. And we don't need to spend a lot of efforts. For example, this part it's like combined copying and computations in the first stage. So when we perform first step of computation, we perform copying in lockstep, which is not and we have time to do it because we don't spend a lot of time with kernels, and we have easy API to do it because just our code size of this function is very small, and like it is very obvious. So just compile time loop, and this is for each loop, and this the while loop is runtime loop. So we haven't, like, if you look into C+ implementations, you may find a lot of macros. Furthermore, functions like dozens or like hundreds lines of code are marked like macros. It's like a generic C style when you mark the whole function like macros. And this is like this macros is used to inline something or to produce like some generic concepts. So let's move forward. Sorry for off topic.
Ilya,
So, yeah.
we're hoping that only 2% is left. It says 98%.
In terms of time of presentation, or what?
Okay.
Do you mean 2% for D? No, I think D can get 6% in the future, but we need to be a really better C, not a high-level language complex runtime like Go or Rust. This is not a direction.
I see. And actually, Walter Bright raised the better C topic again recently. Have you followed it?
Yeah, it was raised after Mir Glass. So the concept was that Mir Glass should be ported to other languages, and this requires better C. So Walter wants Mir Glass to be compiled with DMD.
Okay.
And it can be compiled as C library today, but with LDC only. So it supports LDC only for now. Of course, DMD support is possible as well as GGC, but we need like few language additions, like unaligned memory store loading with a generic API like LLVM has. And we need like a few permutation operations with a generic style like LLVM, and like some other LLVM features I have a page, like I have a list of these features, like, but this is out of this presentation. So what I propose to do is on the slide. Like, let's discuss this one by one. So first is D, and this is like a beta C language with a reduced amount of language features. For example, a current associative arrays, object-oriented concepts are not allowed to, but we can use generic style programming and like a structural typization, like for example in std allocator. And it's like std allocator is a good example of what kind of phobos we should have. So first it is building blocks. Then we have it's like there are some like backend blocks like C memory allocator. Then at another blocks like generic approaches, which allows to combine different algorithms, different like levels of memory usage for different memory block sizes and different memory storage logic. So it's like, it's simple, it's component by it, it's generic. So the same direction is good for runtime and for phobos. So D should be packaged with like a slim generic std. It's like models like std2.8, std meta, std range primitives, maybe some other models too, but this is like very simple, portable, and without any one-time requirements. Instead of the like basic runtime, we can just have a proper API for libc. We already have it. It is like core SDC. We have math functions here and a lot of other stuff. These functions are not citafiable, so I propose these approaches to be part of generic std blocks, like citafiable math. It's listed here. Another feature is another part. So it's like a low level, slim standard library, generic std and libc. Then we have building blocks for runtime, building blocks for building generic blocks. They can interact it, like blocks from left can interact with blocks of right and vice versa. But all this should be clear. So we should have a small dependency graph, and this graph should be explicit. So if we use something, we need to understand what components will be used. And we need to have a clear API, defined API. And we need to have a versioning, independent versioning for different blocks. So we can override version, for example, only for suites. We can, for example, we write our own suites. And what we want is that we can replace the version for suites with, for example, a path to local to our local implementation. This approach is already implemented in dap.json, in dap.json SDL. We can override a version of packages with explicit path in our file system. So this is very cool because we can fork only one package, like make a fix or make an addition, like port it to another architecture. And we don't need to fork for all D runtime. And because we have if we will have a clear dependency graph, we can estimate amount of possible work we need to do it. Because currently, when we need to do it, it's not obvious how much time we spend to make like some addition to make bug fix, like fix reads, like very small pair changes, and you need to fix everything in your time, like because then when you fix everything, it compiles and you start it and it doesn't work because like some third models import this feature and it use like behavior that it wasn't defined in documentation. It just wasn't defined in. It was not clear that this behavior exists. For example, so it's like D runtime should be like a blocks which are splitted, and this is a way how we can this is a way how companies can invest into D runtime, because they can build something and they can be sure that this would work, and in this infrastructure they have more opportunities to communicate with the community, with the developers, because currently we have one team, and this team is very small. We cannot have, like, for example, a big team for D runtime, because big team is like a lot of opinions. But if we have a building blocks and each blocks has its own own set of developers, these sets of developers are intersected between different runtime and std blocks. So we have like a network of developers. They are partly independent. Some persons are present in different communities, in different teams, and this is some like packages. For example, HTTP2 has a good community and commercial support. Like, this is what I want to move to. So on. What the next step is what D runtime blocks I think we should implement. The first is like basic event loops, suites, low-level suites without like workers or something like that. Just a very teeny, thin, slim abstraction on top of operating system API. All this should be generic, like structural programming without object-oriented style. Then like fibers are the same, so we can like very slim shell on top of different operating system APIs. Because it is generic, it can have very small additional computations comparing with C implementations. So because C implementation has like runtime information, we can eliminate a lot of runtime information for suites and for fibers, and for general for D runtime, if we will use an approach like which is used in std allocators. The same for async input-output. More interesting is that we may have a generic event loop concept, which like a set of like a generic set of rules to generate basic event loops. For example, if we implement a common basic loops, or we use a standard C library like libevent, libf, libev, we wouldn't write event loop which beats like a specialized C libraries. So it is not possible. The reason that if we use fibers with events, and if we use like just event loops, they have their own buffers. And instead, because that like we sometimes need to make an additional copy of data. We need to have like runtime information. But if we have a generic event loops, what we can do? We can eliminate some runtime information. Then we can extract event information, like define event information for HTTP2, integrate it into generic event loop, and instantiate it into like a precompiled basic like event loop. So like the idea is to have a building generic event loops, building blocks to like std allocator, and to generate to define like a set of operations, set of events, define set of compile time handlers for these events, and these events can be integrated. Can be like so. Then we can have like something like compile time compiler, like internal compiler. So the same approach is used in mir. So we just write a generic concept, and this generic concept generates a performant loops depend on operating system, depend on architecture, and depends on our configuration. Like Glass is very small evolution comparing with what we can do in terms of event loops, in terms of high-level performance applications. So Glass is awesome, but it's like very, very small. It's good proof of concept, but why it's good? Because we can write a code and we can show this works. We can show that it is fast and it is good enough. Like one component. So scientific software are good, already good, like single components. At the same time, runtime infrastructure are good when we have a lot of different runtime features, like listed here. And it is useless if we have something from this. For example, it's useless if we have async error, it's useless without suites, it's useless without event loop. So runtime is like a big project. But if D is only language which can implement generic D runtime, which can be fast as specialized C libraries like H2O for HTTP2. So this is like a small, like my dream to work on, and like a big project. So, but we need to start this project. We need to see that we have now like time and now like financial opportunities to finish this project. In the same time, scientific packages can be done one by one, component by component, and these components can be used already by one without another one, without implementing all infrastructure in D. So
sounds great. Have you raised this already with other people?
I have discussed it some moments with Andrei and with Tamedia Digital. So Tamedia Digital hasn't cannot maintain this project by itself, for example. and the D foundation is very young. So the good point about my talk about NDA is that, as you may already know, a few students from, probably 3 students from Europe started to work on D infrastructure. They are system engineers, and Andrei, I think that Andrei is open to work on this concept. So I think that he expect like some kind of feedback from the community about this concept. So like I think I think that the students can work on this stuff too.
Yeah, awesome. So we're waiting for those students to become productive. They are in the learning phase right now.
Yeah, so yes.
Yeah.
On the left side, there's like an algorithm, data structures, and data formats. First, I think that the same we should have a very small dependency graph here.
Ilya,
Yeah.
so we're running out of our time here. We will be kicked out soon. So we're anxious to see your last slide pretty soon. Thank you.
Okay, so we have a very small time constraint, yes?
Okay, great. Yeah, we have to wrap up here.
Okay, so I just show you the proof of concept, and we have few slides, and I will finish. So the 2 packages, mirGlass and mircpuid, they should be linked together to use Glass. This is like a normal because, for example, Intel MKL requires to link few libraries too. They're both C libraries. This is a graph here, so you can see that it's complex single precision. You can see that mirGlass is has almost the same speed like Intel MKL. OpenGlass is slower. The reason why OpenGlass is slower is very stupid. They hasn't runtime CPU identification. They run like a script to determine CPU sizes during compile time, and this script uses only compile time information about CPU cache sizes. For example, for different architectures, it has like predefined CPU cache size. So I think this is the reason why OpenGlass is slower here. mirGlass uses mircpuid library, which determines CPU cache sizes during runtime. Like I think that Intel MKL do the same. The second, like why Eigen is slow. I think that Eigen hasn't like released version of RAX. It has good support for non-complex numbers, but for complex numbers, it is very slow, probably because it's either a wrong blocking sizes, so they doesn't fit into CPU cache properly, or it just hasn't backend implementation for complex numbers right now. So it may be improved in the future, but it requires significant efforts. So, and I have no idea why Apple accelerated is so slow. This is part of mirGlass .json. Please keep your attention to link once templates and LDC flag and build mold single file. This is things you need to do to build a better C library. Link once templates, remove template bloat. Like if you generate a lot of template functions which are inlined, in object file, without this flag, these functions will be represented too. So your library will be few times larger without no reason. So the code will be just duplicated. And to use the flag, you need to have to work with build mode single file, because without this, because compiling like composite, you'll have problems using one templates. Also, single file allows to build your project in parallel mode, which is not like common today in the infrastructure. Like the list of like some information about migrass, I have already discussed it here. The good point is that it passes netlib test suite. This is awesome. So we just link, we just have object files. We link this with other object files and send it like packet like C library, and passes like argument to compile time argument to netlib's test suite. So it compiles a tests and runs this tests which are written in C. So this is like very cool to have to reuse C code in the project by running code by C side. What?
No, we have some echo. It'll be.
Oh, sorry. Okay. We have C++ coders. This is very cool because, and we also have C examples which are part of continuous integrations as well as netlib's test suite. And we don't need to have any dependencies like the runtime or Phobos, like precompiled Phobos. So just a normal C library. This is like good things about mir cpuid. I have already, like, for example, it has an extendable API, but we haven't a lot of time to discuss this, so I will skip it just now. This is more important slide. This is a slide to represent how we should organize our source codes to write a better C library. So when we have a pragma inline false, all this code should be instantiated if this generic or not generic doesn't matter only once. So if we have different, for example, in mir, each generic function for instantiated only once for double, only once for float, and only once per complex types. So we doesn't instantiate big templates and we doesn't compile non-inlining functions twice or more. This is like a C++ and D problem, because if you have a very big project, you cannot, and you try to build it like in single file mode, it will be very slow. So D has a DMD compiler which is fast, but when we build like with LDC, it is slower than C currently. So to make it fast as C compilers, we need to use a single file parallel, and we need to use to organize our code to be compiled only once. So it just this graph, this gem represents how this code should be organized. It's very simple. And good point about headers is that it was like a very like surprising for me that headers makes implementation clearer. So we can so first we make compile time slower, faster, and then we make headers allows to have an abstraction for better C library. So it makes like your internal infrastructure more clear. So just don't think that headers is like from previous age, it's currently actual too. It's like good for low-level system programming. What means extern C? Extern C means D derivative, so it is D code here. Also, you can have an additional C headers. Extern C means this D headers, but they are extern C. Make it as extern C. On the right side, you can see piece of D code. This is like instantiation of generic code which should be compiled. So we have the same code for different types. It should have its own interface. So it will look like this is like a small library, small files with generic interface. It use it is like a string which has an alias to type, which was passed like double or float or complex, and we used a prefix for gem, like S for double, S for single, D for double, and other prefixes. Then we call just generic implementation, which is inlined, and in this we in the Fortran API, for example, we import. We have like small runtime code for errors, and we just call a header instead of like generic, because like redirect a function. And how this works in precompiled? So we have a precompiled folder, and we go and we are here. There's 3 lines of code for double and for float. In C libraries, how it's done in C libraries? C libraries uses preprocessor, so just copy paste all code like multiple times, and you may find a lot of like such end of lines for C microprocessors. Okay, let's move forward. We have only a few slides. This slide about what I can work on. First is like algorithms. I have a statistical background with experience in machine learning, in data mining, and another one is more like complicated projects, is runtime and production projects. So we haven't a lot of time to speak about it, if I understand you correctly. So if someone wants